Hello, welcome, and thanks for participating in this webinar, which is the second of a three-part series looking at biochar used in different applications. My name's Harry Grote with Dovetail Partners, and at this point I'd like to thank Kathleen Draper, Ashley McFarland, and Tom Miles for their invaluable contributions to this project. And I want to thank the Forest Service for their support, which has made these webinars and the research and detailed reports on which they're built possible. I'm going to move pretty quickly through a review of the project and what was learned about this particular use of biochar in order to maximize our Q&A time. And I'm going to turn off my video at this point too. The project team selected 3 applications where biochar's potential to benefit users was significant and which could use significant amounts of biochar made primarily from woody feedstocks. Choosing the market to serve livestock producers using biochar was initially focused on animal feed due to the successes Europeans are seeing. However, as we dug into the research and talked with North American farmers and ranchers, we saw the potential of biochar in manure and bedding management. That was particularly exciting because it uses more biochar, which sequesters more carbon, and because it all ultimately ends up in the soil. That's good because there's a ton of evidence about the positive benefits of biochar in soil, so we expanded the focus to include both uses. We looked at users' experiences, recently published literature, as well as the size and scope of growers' needs. There's a comprehensive report which details what we learned. The link to it is in the one-page summary you received and can be found on the website where we're archiving the webinars and follow-up information. I think that link's in the chat already or will be shortly. Here are the highlights from the full report. As you can see, biochar has been used beneficially with livestock in both manure management and as a livestock feed. As I said earlier, there's a lot of research supporting biochar's benefits, but it ultimately ends up in the soil, as in manure management and as a bedding additive, which has the added benefit of reducing ammonia and methane. There are many businesses using biochar as an enhancement to their compost, which I'll speak more to in a minute. The most comprehensive experience of using biochar as a feed supplement is in Europe. There's only been limited research on that use in the US and Canada, with the results to date ranging from neutral to positive. However, the primary barrier to biochar as an animal feed is regulatory, which I'll address after a further look at biochar's unregulated use in manure management. This graph illustrates the potential for using biochar in manure management. This data is from California, and you can see the impact biochar's methane mitigation capability could have if used more widely with livestock. You can also see there the benefits of using that biochar enhanced manure and compost in an agricultural application as well. In this next slide, from a recently published look at a number of meta-studies about biochar's co-benefits. Note the number of individual papers the meta-studies represent on the right is in the hundreds and thousands. Looking at the various parameters of agronomic relevance along the central column, you can see there are a lot of positive outcomes with biochar by the bars to the right of the center line. And looking near the bottom at what appears at first glance to be negative effects because the bars are to the left of the center line, those are actually positive outcomes because they represent reducing various emissions and heavy metals. I really recommend downloading this open source paper and reading it. The link is in the chat now and is also on the Dovetail Partners resource page. Now, moving on to the use of biochar as an animal feed, one reason the bulk of experience with biochar as an animal feed is in Europe is because they have a standard for its use as a feed supplement. In the U.S., the FDA regulates animal feed involved in interstate commerce. Many states use the FDA regulations as their standard too, though some states have independent regulations. While the FDA has the regulatory responsibility, the American Feed Control Officials, or AAFCO, sets the standards for what feeds and additives are considered safe. So until the AAFCO approves biochar as an animal feed, its use will require FDA approval on a case-by-case basis. The problem for livestock producers in the U.S. is that the AAFCO considers biochar as a wood charcoal with potentially deleterious characteristics, as you'll read in the next slide. As long as biochar is lumped in with charcoal, which is typically used as a fuel and made at a lower temperature and therefore retains many of the contaminants you see mentioned here, there is a significant barrier to widespread availability of biochar as an animal feed anytime soon. Given the existing European biochar certification standards as a model, the U.S. poultry, livestock, feed, and biochar communities really need a working group to explore how to gain AAFCO and FDA approval for biochar itself as an animal feed. The FDA regulations and the European biochar certification requirements are included as appendices in the full report for your convenience, and you have the link to them. If you'd be interested to participate in that effort, please put your name in the chat with a working group header or include it in the post-webinar survey, or send an email to USBI. Since biochar isn't like generic charcoal and its characteristics can be well defined by managing the feedstock and processing conditions, standards like the EBCs are needed and quite feasible. Now, moving on to our speakers. After a brief intro about biochar from Kathleen Draper, we'll hear from two speakers who've been producing and using biochar with livestock and poultry. Afterward, we've invited two experienced researchers to join us to answer questions. Kathleen Draper wears many hats in the biochar, though none yet are made of biochar. She focuses on research, writing, education, and consulting in New York and globally. She's the IBI board chair, is a USBI board member, and co-author of the book Burn, which looks at how we can harness carbon to help solve the climate crisis. Mike Calicrate is a farmer, rancher, business entrepreneur, and family farm advocate. After college, he started farming and ranching in St. Francis, Kansas. In 2000, he formed Ranch Foods Direct, a branded beef company and retail and online store located in Colorado Springs. The company also operates a regional food hub, helping to collect and distribute locally produced food. In recent years, he transitioned his cattle operation in northwest Kansas into a multi-species regenerative agricultural model with hogs and chickens as well as cattle. Wayne Teal is a professor in the Department of Integrated Science and Technology at James Madison University in Harrisonburg, Virginia. He teaches mostly environmental science, agroecology, and sustainability. Most of his current research has something to do with biochar, and his latest work involves dealing with poultry waste and using biochar to reduce the negative impacts of that waste. Andrea Watson will be joining us for the Q&A. She's a research associate professor in the Animal Science Department at the University of Nebraska-Lincoln. She teaches and is conducting research focused on nutrient cycling through agricultural systems, concentrated on the use of carbon and nitrogen in cattle diets. Heather Kingry will also be joining us for the Q&A. Heather is the Forest Products Specialist for the Nebraska Forest Service. She's been working with biochar since 2013 and focuses on agricultural solutions to forest management challenges and the role of wood-based biochar. She's also a USBI board member. Now let me turn it over to Kathleen.
Thanks, Harry. I'm going to try to pull up my couple of slides here. So first off, thank you again to Harry and Ashley for not only hosting this series of webinars on biochar markets, but also for gathering the research and practical information on the use of biochar in vineyards, in livestock farming, and in stormwater management. On behalf of the International Biochar Initiative and the US Biochar Initiative, we are always happy to welcome new folks with diversified backgrounds and interests to the biochar community. For those of you new to the biochar topic, and I'm sure there are a few, it can initially appear a bit too good to be true when you start to learn about the various uses and benefits of biochar. And much as we'd like it to be, biochar is not a silver bullet to our climate woes, nor is it some type of medieval alchemy. The fundamentals of using heat to convert short-term sunlight-derived carbon into a more durable form of carbon, thereby preventing it from converting back into CO2 and returning to the atmosphere, is pretty straightforward. After all, Mother Nature has perfected this process over millions of years by using a little something called fire. However, there is substantial variability in that durable carbon being produced, what we call biochar, when high heat and low oxygen technologies are combined with a wide variety of organic materials. And the applications for those various types of biochars has begun, and I believe will continue to expand exponentially, similar to what we saw a century or more ago happen with fossil fuel derived carbons and other co-products. No longer are we just looking at putting it in soils, but biochar can now be found purifying water, improving soil, stormwater infiltration, remediating brown fields, capping abandoned oil wells, reducing embodied carbon in building materials, and improving feed for livestock, who then distribute this long-lasting carbon into pastures and paddocks. And in case you're interested, this is a picture of my family's farm in upstate New York. Whoops. Our indigenous ancestors figured out how to use fire not only for cooking, but for managing excess nutrients and waste, which simultaneously managed to significantly increase soil fertility. It's pretty unlikely that they understood that while they were doing that, they were also preventing about half the carbon absorbed during the trees and plants' lifetime from returning into the atmosphere. But it's this latter aspect that has captured the interest and imagination of a growing number of individuals, investors, corporations, and countries. One of the really great things about biochar is that this critical role of safely sequestering carbon comes with so many potential co-benefits, whether it's used in soils directly, as Harry just outlined, or used in animal agriculture, or used in a growing number of composite materials. Ever since the IPCC special report in the fall of 2018 highlighted biochar as one of a half a dozen negative emissions technologies that could have a material impact on rebalancing atmospheric carbon, we've seen an absolute explosion of interest in our fledgling but newly flourishing industry. That includes investors, carbon markets, carbon removal buyers, governments, corporations with large organic waste streams, or that have committed to science-based reduction or net zero targets. We're even starting to see farmers and ranchers encouraged, and to a growing extent, that means financially, to increase soil carbon. If this webinar whets your appetite to know more about biochar, there are a growing number of ways to learn more, some of which I've outlined here on this slide. It can be a bit of a black hole when you first dive into biochar, as there are thousands of peer-reviewed articles already out there with thousands more published each year. Plus, there are a growing number of online and in-person events that can help. One other word of warning is that it can sometimes be hard to distill the hope from the hype or the fact from the fantasy. But here are some of the sources that I believe will provide a relatively unbiased perspective on biochar. And of course, we would welcome you all to join IBI as an individual or corporate member, which will provide access to even more biochar information. Just as a follow-up to what Harry said, if you're interested in helping on a small subcommittee to focus on getting livestock feed reapproved, biochar reapproved for livestock feed through the FDA, please send an expression of interest, which would include your relevant experience either on the livestock side or the biochar production or research side, or if you have policy or lobbying background, that would be really helpful. And you can either send that to USBI or to me directly. It would be more helpful to send an email than to put it in the chat because we might not see all of them. So I'm sure you'll enjoy this great presentation by Mike and Wayne, and we look forward to seeing what some of your questions are. And if you have ideas for future topics for these webinars, please let us know. So Mike, I'm turning it over to you.
Thanks, Kathleen. I'll get up. Can everybody see it? Can you see the screen okay?
Yep. Yep.
Oh, good. Sorry, it just took a minute for me to get that up. Thank you so much for having me on today. And I know Kathleen talked about how exciting biochar is, but not to believe it's a silver bullet. But in what I do in the livestock business and meat business, I honestly don't have anything that I'm more excited about than biochar. It is an amazing product, and so at Calicrate Cattle Company, we let's see. At Calicrate Cattle Company, years ago, probably 7 or 8 years ago, I had Darren Doherty come out and he did a 10-day REX, regenerative ag course at our facilities there at St. Francis, Kansas. And we were slaughtering our livestock on site. One of the moves we made about 20 years ago is we formed a company called Ranch Foods Direct so we could sell directly to consumers as opposed to the big meat packers. And Darren asked the question, well, what are you doing with your bones? And I said, well, we don't know. We haven't really figured it out yet. We're composting them in with the slaughter waste, but we, at the end, we still have bones that didn't fully compost. He says, well, you should look into maybe charring those bones or cooking those bones. And he had a person in Mexico that had done it. And so I started looking into it, and I got really interested in that possibility of turning bones into bone char. And so in our process at Calicrate Cattle Company, as far as our circular sort of economy with regenerative farming and ranching, it's all about the soil. So you start with the soil, and we want to go back to the soil and keep as many of the resources as we possibly can close to the farm, and while producing really high quality products. And so we went ahead and got a retort. This is the retort that we have at Calicrate Cattle Company, and basically this is just an exeter retort. It's got an inner chamber and outer chamber, and so it's basically the inner chamber is an oxygen-free chamber, and this will get the internal temperatures up to over 900 degrees. And as you can see from those bones, those are fully carbonized. All of the organic matter has been cooked off of those bones. And then after you char those bones, they're very easy then to run through a grinder or a roller or some sort of a method to break those up. You can even use a front end loader on a concrete slab and drive over them. But what we did then is, once we got those bones turned into char, which is a really valuable soil nutrient, which we sell at Ranch Foods Direct to gardeners and people, you know, growing things in our area. It's particularly interesting because it's around 35% phosphorus, 33% calcium, and the balance would be carbon. So it's a fairly low carbon product, but it's high in other essential nutrients that are very expensive to go out and buy in the fertilizer market, especially today. And of course, we've got all the data from years of studies of the difference that can make in the soil. So one of my biggest areas of interest is why aren't we feeding biochar? And I look at the USDA and the FDA's worry about contaminants. It's weird. We've never found any of those in any of the product that we've made. And this biochar you're seeing right here in this picture is hemp. We started turning hemp into biochar when the hemp industry started up in Colorado, which is just across the border from us at St. Francis, Kansas. So biochar as a feed ingredient, I think is the most exciting thing I can think of, and we need to work very diligently to get that approval as soon as we can. Biochar, that is carbonized biomass similar to charcoal, has been used in acute medical treatment of animals for many centuries. Since 2010, livestock farmers increasingly use biochar as a regular feed supplement to improve animal health, increase nutrient intake, and thus productivity. And Kathleen was one of the authors of this paper that I reference quite often, where it's, as evidenced by farmer practice, veterinary advice, and European regulations, biochar is already widely used as a regular feed supplement in cattle farming, especially in Germany, Australia, or Austria and Switzerland. So it's proven in the European countries and has been used for a long time. And so more recently, it was rediscovered or discovered that blending biochar with organic amendments such as manure, cattle urine, or compost may increase yields more significantly in a broader spectrum of climates and soils. And this is where we're able to put the biochar or the bone char into our composting operation and actually charge that biochar up with the nutrients that find their home in all the little spaces of the biochar. So we really like putting our biochar into the compost pile prior to spreading onto our fields. This apparently favorable combination of organic residues with biochar prompted researchers and a rapidly increasing number of practitioners to conduct trials where biochar was not only mixed with manure, but also included as an input into animal farming systems. Unfortunately, that's not approved here in the United States so far. In addition to the direct benefits for animal husbandry, as discussed below in detail, biochar becomes thus enhanced with organic nutrients, which increases the economic viability of biochar application while providing numerous environmental benefits along the cascading way. Since 2011, German veterinarian Gerlach has been feeding 100 to 400 grams of high temperature wood char per cow to numerous herds of cattle without detecting negative side effects. Overall health and vitality has improved with 25% in another study, 25% higher weight gain. And this is very similar to other data that I see from people that I talk to around the world, and some from Australia. When combined with silage, biochar can reduce mycotoxin formation, bind pesticides, suppress butyric acid formation, and enhance the quality of lactic bacteria. And this gets back to the Federal Register posting the National Organic Program and amendments to the national list of allowed and prohibited substances. So activated charcoal has been listed as I read it, as a therapeutic option for ingestion of toxic plants and control of diarrhea caused by moldy silage. And so some nutritionists that I know would look at this and say, you know, I guess we can use it for a treatment. But what is the difference between the activated charcoal, which has been approved or at least listed, and biochar? So there's a lot of clarification that needs to happen. The people I talk to that are feeding biochar in other countries are typically incorporating into the ration or diet, the daily diet of the animal, at about 1 ounce per head per day, or right at 1/4 of a cup per animal per day. That would be about a 0.002% percentage of the ration, which is less than what we would typically see in a ration is ash or inert material at around 3%. And so it's a very, very low inclusion rate. And so these are things I think we can look at as we look to get approval as we go forward. The other thing that we see from the people I talk to that feed it is the incidence of bloat has been almost eliminated, essentially eliminated in the diets where biochar has been incorporated. And as we look more towards natural diets, trying to reduce the amount of antibiotics used, like Rumensin, Biotech, or the various ionophores, and then the use of Tylen to address liver abscesses, which is a result of too much acidosis. Biochar can be very, very helpful in reducing some of these antibiotics. On a cautionary note, not all biochar is the same. This was an extremely troubling event here in Nebraska, where they were turning treated seed corn into ethanol and then trying to sell the toxic biochar into the marketplace. So we've got to be careful. There needs to be some standards set, and there needs to be some framework around the use of biochar and how it is made and what it's made of. And so the question becomes, how can biochar gain wider general use and acceptance in livestock diets? So carbon catches a free ride to a permanent home. One of the funnest videos you'll look at is if you go to cattlecratecattlecompany.com and click on soil products, you're going to be able to see Doug Powell's video of how he is feeding biochar to his cows, and then the dung beetles are burying it in the ground as much as 200 millimeters, which is close to 20 inches deep. And so basically what Doug is saying, that the Ruminant Dung Beetle Partnership is putting carbon in the ground permanently without using a machine. And so he says, and he's got enough data now that he can be fairly confident. All parameters are up, and we're doing it economically, biologically, and profitably. It's something the cows don't mind eating, and the beetles don't mind burying. So how do we get dung beetles? Well, we quit spraying everything. We try to build the population of dung beetles, and someday, if we can start feeding some biochar, this could be a very exciting way to get carbon back in the land and repair much of the damages of the industrial model of agriculture that we've used for the last 50 years. So at Calibrate Cattle Company, we have a screener that does the final screening of the slaughter waste manure compost blend. So after slaughter each day, we haul our slaughter waste off to the manure pile, where it's blended with the biochar, bone char, and then it's composted over time, and eventually it goes through this screener where the finished product then is spread on our fields. Kathleen already talked about the benefit of turning biomass into biochar prior to it degrading into carbon that goes into the atmosphere. So this is a very exciting thing, I think, for agriculture to offer to climate change and to reducing carbon in the atmosphere, is that we could do a lot more conversion of biomass into biochar prior to its disintegration. And here is just a visual. It's taken the same day in the same field with and without biochar. So there's very, very significant benefits here. And it's also important to know that that biochar needs to be charred or charged, excuse me, charged prior to being applied to the soil. Otherwise, it can reduce your yields due to its sort of sponge effect and absorption of nutrients initially when it's applied. This is a manure spreader that we use on our place. It's specially designed for compost as opposed to raw manure, and it applies a uniform blend of manure, slaughter waste, and biochar, bone char to the crop and pasture land. And so what if ruminant animals could be returned to the land along with their precious soil building manure? There's a lot we need to do to get that to happen. We need better markets for one thing. We need to rebuild our cow herd. But this is a picture of eastern Colorado. I fly over it when I go from St. Francis, Kansas to Colorado Springs. And it's just so sad to look at the soil loss. Most of the soil, topsoil is gone in eastern Colorado on land that's been farmed. And they've farmed over the years, they've farmed the very most marginal land that they should have never broke out as farmland. And then they'll put it back into CRP, the Conservation Reserve Program, get paid for 10 years, and then they'll break it out again and do it all over. And who loses is taxpayers and people who in the future want to eat. And so what if we could bring animals back? And that's a big thing that we really, I would like to see happen. But what if we could bring them back and see some biochar mixed in their manure? How could we heal this land and make it productive again? Make it less dependent on chemical fertilizers and chemicals. So at Calicray Cattle Company, we believe the ideal farm is family owned and operated, diversified and livestock centered, responsibly grazing and feeding the farm's production with animal manure going back to the land. Thank you.
Wayne, I think it's over to you at this stage.
Okay. Can everybody hear me?
Yep.
All right. There we go. Okay. I don't think I'm getting any feedback, so we'll be okay in the classroom here. I'm actually in front of a group of students at James Madison University because this seminar happens at the same time as my class. What I'm going to be talking about is mixing biochar in the poultry industry, which is really big in the Shenandoah Valley here in Virginia. Oops, what happened here? My slides are out of order suddenly. Hang on just a minute. I seem to have a little technical difficulty. Oh no. Okay, I have a bit of a problem here. Sorry about this. Just a second. Shoot. I tried to change the slides in my thing. Is it possible for you to share the slides I sent to you?
Yes, give me just one moment.
Do that. I'll just tell them where it is. I'll stop sharing here. My fault. Okay, go ahead. That's great. And then you can go ahead and go to the second slide. You're going to have to click through it when I tell you to. So go ahead and click the first thing to get the next line. Okay. Just hit the down arrow on this. There you go. Okay. So one of the things about birds that you have to understand, everybody, is that they don't urinate. They combine uric acid with feces. And so when we're dealing with a poultry house, we are actually dealing with a semi-solid waste product that's going on to a bedding inside a poultry house. And this uric acid then builds up in the poultry house and it begins to give off ammonia. The ammonia that builds up is pretty unhealthy. And I have a student right now who's going into one of the houses that we're working in with an ammonia meter, and it gets up to approximately 55 parts per million inside the house. The disadvantage of this for the birds is that they have to live in it 24 hours, and humans can just go in there for 5 or 10 minutes and check them out and then leave. But living in there for 24 hours inside these poultry houses means that they actually get some problems with tracheal lesions that can cause bacterial infections that lead to a premature death of the poultry in the poultry house. And so these are birds that cannot, even in an organic farming situation, escape the poultry house. They're basically stuck inside. And so the idea of giving them biochar in this setting, whether you're giving it as a feed additive or as an additive to the bedding, is to try to reduce that ammonia emission in the houses. And so we had the opportunity to do that. Next slide, please. Okay, so in this particular setting, we're starting to work with a company called Shenandoah Valley Organics, which is a relatively new poultry company in the Shenandoah Valley. Most of the poultry situations that we have here are large corporations like Tyson, Purdue, George's Chicken, and then Cargill with turkeys. And they have fairly large houses, but they don't allow innovation in either the bedding or the feed. So we're working with Shenandoah Valley Organics because they're much more open to innovation, especially at the farmer level. So we introduced one farm to biochar, and the initial try, which didn't involve very much biochar, we realized that the chickens really like to eat the stuff. They didn't just have it in the bedding, they picked it out and ate it. And that made the farmer very enthusiastic. And so he was willing to let us try adding biochar to one of his poultry houses and leaving the other poultry house as a control so that we could compare. So the control house has 15,000 birds and a fairly strong ventilation system. And we added approximately 38 cubic meters of bedding. Okay. The older house, which is 12,000 birds and a weaker ventilation system, had 30 cubic meters of bedding. But in this one, we added 5% biochar by volume, or about 1.5 cubic meters of biochar, using the hypothesis that the biochar would absorb ammonia, as stated in the literature, and the ammonium ion trapping it and lowering the ammonia emissions in the house. But it did not work out that way quite. We ran into a problem. Next slide, please. This is how we make the biochar. This is a design that I got from Kelpie Wilson at Wilson Biochar Associates out in Oregon. They use a flame cap kiln. So it's a method that you can use actually in the woods or like at my house, which is where this is. And we can make approximately about 100 liters of biochar in this at a time. Or maybe a little bit more than that. And so this is the biochar we used. Next slide. And it comes out looking like the picture on the left. Then we use just a regular old chipper shredder to grind it up so it looks like what you see on the right side of this particular picture. We took that, all 1.5 cubic meters of it, and we took it to a poultry house. So next slide. Oops, okay, just before that, I just wanted to note, in this particular picture, and perhaps you can see the cursor as I'm putting it across, there's a lot of poultry houses in the Shenandoah Valley. This is a small fraction of what we have around here that we could put biochar in if we wanted to. There are numerous ones in this picture. We have over 900 poultry houses just in this area of the Shenandoah Valley. So that is where we're putting it, inside one of those houses. Okay, next slide. Okay, so as you see this coming up, this is the bedding spread in the older, smaller of the two houses. This is a 12,000 square foot house. They're going to put 12,000 birds in it, so about 1 bird per square foot in terms of there. And that's the way we spread out the biochar inside the house. Click it down again. Okay, so when you get the chicks in, they almost immediately start feeding, and then they eat the biochar. But as you notice in the picture on the right, after they grow for a while, the contours of the bedding change. Basically, the birds are pooping on it enough that it is covering up the original bedding. And as they trample this down, you begin to get a different characteristic of the chemistry in this particular place. At first, the biochar actually works to keep the ammonium level down a bit. But, next slide. As the birds grow, they basically cover the entire bottom of the poultry house. And so does their manure. And what this does is it puts a cap on the top of the bedding, creating an anaerobic environment. And when the anaerobic environment begins to take over, you can get gas emissions. You can see it more clearly in the next slide. In this particular slide, you see the birds basically sitting on this surface, but you cannot see any of the original bedding or the biochar. They've basically capped it. And one of the things you'll note about this situation, and this has been marked by the researchers in Germany, Hans-Peter Schmidt, among others, who have basically said that in this kind of situation, the interaction between the bedding and the bird creates a problem for the feet. Their feet basically get lesions and they get sores just the same way as the trachea inside the lungs of the bird are affected by the ammonia. The bedding actually has a negative impact on their feet, and they don't scratch. So that doesn't open the litter to allow oxygen to penetrate, and you get this anaerobic environment. Next slide, please. In this house here, what happens is that you're getting relatively low interaction of the bird's feet with the biochar, and so ammonia is given off. And because this older house has poorer ventilation, even though it has the biochar, it actually ended up with higher ammonia concentrations because it wasn't able to get sucked out of the house fast enough. And so that was the cause of the problem. And so we've had to step back a little bit and rethink what's going on with this process. And that's what we're going to do in the next phase of our work. Next slide, please. Okay, so what we're trying to do is look at how rapidly the fecal material coats the bedding, and to see if we can get it in such a way that we can keep the chicken's actual tendency to scratch things operating instead of having their feet have all kinds of problems. So next slide. What we want to do is try to get rid of that moisture cap that is on the bedding. And in the winter, that is actually harder than in the summer. In the summer, they keep the ventilation system running, and so that helps with the evaporation of the bedding, keeping it drier. But in the winter conditions, when they're not running the ventilation system so much, it actually is wetter. And so we don't want this anaerobic conditions, because that not only leads to ammonia emissions, it's also leading to methane emissions and nitrous oxide emissions, which are both greenhouse gases. And that means our poultry operations are actually contributing more to greenhouse emissions than we thought. So what we need to do is add the biochar, probably more of it, preferably in smaller pieces, and doing so at intervals. Instead of adding it entirely at the beginning, add enough at the beginning so the little chicks can actually take advantage of it. And then every week, add a bit more so that the biochar remains closer to the surface, contributing to keeping the manure aerobic, so we can then keep that aerobic conditions to reduce the greenhouse gases that we're getting given off, as well as the ammonia. And our goal is to reduce ammonia and increase stability of the bedding for fertilizer use on regional farms. The advantage of doing this in an organic house where the feed is all organic is that we will be able to call the product, the manure and biochar mix, an organic product, and probably be able to develop a better market for it. But we are going to need a lot more biochar, meaning that we can't just rely on the smaller flame cap kilns that are good at a local farm or for a small farmer with 2 or 3 acres, but it's not going to be really that effective when we're talking about poultry houses with 25 to 40,000 birds. With that, I will turn it over to the moderator.
Thanks very much, Wayne and Mike. We have had quite the conversation about dung beetles in the chat, but since I don't think, correct me if I'm wrong, Mike, that's part of your operation, I think I'll leave that to the folks in Australia that seem to know a lot more about that than I do. And I just want to say, Mike, you have a way with words. I think I probably wrote this down incorrectly, but I like this notion of carbon captures a free ride to a new home when you feed it to cattle. I think that's a great way of expressing it. I am going to start on some of the questions that have already been posted in the chat. But I'm having a bit of a connectivity issue here. So Ashley, I may need your help for whatever reason here. Yeah, sorry, I'm not able to access the Q&A. Oh, here we go. Okay, sorry.
Perfect.
Yeah. Mike, if you could talk a little bit about the retort, the Exeter retort, and how that works and how much fuel you put in. I think it's wood waste, no, sorry, bone waste, and then how much you get out of it at a time, how long it takes, that type of thing. That would be great.
Yeah, we get about a 50% yield on the biochar, and bone char is going to be more than that because of the calcium and phosphorus that's in it. But it'll hold about 1,200 pounds raw material and produce about 700 pounds of finished product. The retort it's made in England, and we bought one of the very first ones to be sold in the United States. It was built up in Ohio, and if we had to do it again, we would want it to be made of a higher grade steel. It's breaking down. At those kind of temperatures, you really need it to be made out of a high grade stainless, and you need refract material coating the outside or the inside of the outside cylinder to keep that heat from destroying the metal. And of course, we've worked on it a lot. We do have a new design for a different retort that will utilize a skid steer loader, a front end loader type of equipment to load, and also we won't be unloading it by hand. Breathing the dust from the biochar isn't a good thing, and so we're gonna try to make that a lot easier on the folks that do the work and make it more efficient and increase the volume as much as possible. But as you know, in St. Francis, Kansas, or you may not know, but we don't have many trees. So we're more interested in doing our bones, the bone char. But what trees we do have, we offer the city to deliver to our facility and at no charge, no dumping fee, and then we can start recycling a lot of the yard waste from St. Francis, Kansas to build up the other biomass sources.
That's great. Now, the question about cost in terms of using it for livestock feed when you only need a few ounces per head per day is one thing, but when you're using it for bedding, the economics are quite different. So Wayne, I don't know if you want to talk a little bit about your experience there in poultry houses. What might an economical
lost you. Whoops, I didn't hear the question completely.
It looks like we lost her due to some technical difficulties. Harry, are you on board?
Yes.
Are you able to complete that question?
Mike, can you hear me? Hello, Mike.
Yep, we can hear you. If you want to go ahead and repeat the question.
Okay, I didn't know if Mike could. Is he there?
I'm here, Harry.
Okay. The question, shoot, I've forgotten it. I'm sorry. I'm trying to do too many things at one time. I guess, is Kathleen offline?
Yes, she is. We can move on to the next question in the Q&A. And
Okay,
we'll wrap back around to that one when she comes.
Yeah, that makes sense.
Oh, I think I found the question here. If you give me just one moment. So, assuming regulations allow someday I could afford to feed a few ounces per head per day to my cattle and hogs, using biochar in my bedding for the pigs is expensive, though. I haven't figured out how to get a large volume of biochar at a price that works. Any ideas on that front?
Yeah, and Wayne, that was targeted at you.
Yeah, and that is something we have access here in the Shenandoah Valley to more raw materials than Mike has. We've got good forests, and we've also had the unfortunate occurrence of having the emerald ash borer come through and wipe out our white ash trees. So that has been the main woody debris that we have been making into biochar lately, has been the branches of those trees. And that is an impact, but we don't have any commercial producers of biochar in the Shenandoah Valley at this time. There are some a bit of a distance away, but it hasn't been economically viable for the farmers to actually import it to put in their poultry houses. And so that is the limiting factor we've got at the moment. That may change, but it will change a lot if we can actually promote the sale of the biochar manure mix as an organic fertilizer product. And then that would reduce the cost, or at least the economic disincentive to try this. And so it really depends on us being able to develop some kind of market for a product post-use in the poultry houses.
I would think the odor control for the farmers buying it might be a good point to bring up. I don't know. There are a couple of people that are on the webinar today that were with me on a study tour that we did in 2018 to Austria, where they've been using biochar in livestock feed, poultry feed, and as a bedding material. And the difference in the poultry house where they were using biochar and the other ones where they weren't was phenomenal. But the litter that comes out of it had almost no odor, which is incredible. Having lived on a farm where we spread poultry manure, that's a big benefit, and neighbors will thank you.
That is indeed what we noticed in the summer when we had better ventilation, that it actually did reduce odor substantially compared to control. But in the winter, the circumstances were different because of this capping. We couldn't keep the water down.
Yeah. Unfortunately, when I lost connectivity, I lost some of the earlier questions. So Harry, I might need to resort to you reading those, but there are a couple newer ones that I'll just bring up here. Again, back to the Exeter retort, somebody's asking about the heat source. So I think sometimes people don't understand how retorts actually work. So Mike, if you want to just explain a little bit more.
Sure. The heat source is wood at our place. I mean, you can use natural gas or whatever, but we don't want to use fossil fuels. We want to try not to use fossil fuels. And so we break up, some kindling size pieces of wood. And so we start the process with wood burning, and you've got air control at both ends of the unit. So you can get that fire going, and then you monitor the steam that is coming off of the internal cylinder through the smokestacks on top. And when that gets dry, when the moisture is gone, you're basically now producing gas from the contents of the retort, and then it runs on the gas from the wood gas or the bone gas or whatever that gas is that's coming off of the contents of that internal cylinder. That then is redirected back down around into the fire box below. So it's a really cool design, and really all you got to do to redirect the flow of the gas to take the retort up to the higher temperatures is put a cap on the smokestacks. So it's very simple to operate.
Yeah. I want to give Andrea and Heather a chance to talk a little bit about what they have been working on over in Nebraska. Are they still on?
Yes, hello, this is Andrea, and Heather, I'll let you join in as well. So we have done a few trials feeding biochar to cattle, so as a small percent of their diet, as well as using biochar as a pin amendment in feedlots. So applying biochar to the pin surface to help with ammonia emissions, similar to the poultry houses, as well as some mud. So trying to absorb some of that water. We sometimes have to deal with muddy conditions, which can really impact cattle performance and decrease their weight gain. For the feeding of the biochar, really looking at impacts on enteric methane emissions. So cattle, ruminant animals naturally produce methane as part of their digestive tract. And then biochar has been shown in some studies to reduce how much methane is released from the rumen, as well as in something we're interested in following it through and seeing what happens. And is that biochar still viable in the manure? Does it make the manure a more valuable resource?
And maybe Andrea, you want to talk a little bit about your experience working with the FDA to even get these trials going?
Sure, and so that's one of the biggest hurdles so far that was addressed right up front. Mike, I appreciated you covering that, because that is so far a big hurdle where we can't so far legally feed biochar to animals in most situations. And so we got what is called a food use authorization, which is basically a one-time approval from the FDA. We did lots of analysis of the specific biochar we were going to use to show dioxin, furan, heavy metals were not a concern and weren't present in this biochar. And so they have been good to work with and have basically given us the go-ahead on an individual experiment basis to use wood-based biochar. And so I think similar process could be used for bone-based biochar and other. Obviously biochar is a huge term and could be made from a lot of different feedstocks. But so far, that's what we've looked at. Here in the Midwest, have a lot of corn residue, corn cobs, and some companies looking at making that into biochar, which would be a little bit different composition then, but also interest in maybe feeding that or using it as a pin amendment. Using it on the pin amendment, no approvals necessary then, similar to the poultry houses. The cattle could potentially eat a little bit of it. We don't see that nearly as much, but at that point, it's not regulated.
And I'd just like to add that this fall, there was a bill introduced, America's Revegetation and Carbon Sequestration Act, that actually addresses some of these challenges with regulation. And because of the Food Use Authorization, Andrea's group was really only able to look at this one type of biochar, which really limits kind of the information that we're able to collect, right? Because we know that biochar made in different ways and different feedstocks can have an impact on kind of the end use. So the America's Revegetation and Carbon Sequestration Act talks about a pilot program for research for national food use authorizations for biochar as a feed additive for cattle. So at this point, it's just been introduced. It's not moved forward. I think that's coming this year. And that would potentially provide us a lot more information than we've been able to get with this one approval.
And that would really open up research, right, to be able to look at more broad categories of biochar, more applications of it, and would be extremely helpful.
There was a question that gets to what kinds of animals you can and cannot feed biochar or activated carbon to. And I think there is a focus on those that enter the human food chain. Is that right?
I can take a stab at that, but others pitch in as well. But yes, so any animals that would be entering the human food chain. So beef animals, for example, or swine that are going to become pork. Then there's also dairy cows where the milk would be the product entering the human food chain, but they would be considered under that as well.
And then there has been some discussion about at the state level, certain states are now allowing biochar. California, supposedly. Do you want to talk a little bit about that?
So I don't know as many details on that other than really what you just said, that California, it is now approved. And so they have come in with a state level regulation that I guess supersedes FDA approval. And so in California, a lot of dairies and quite a few beef operations as well, speaking from the cattle side, certainly other livestock species are impacted as well, where it can be fed. There are a few instances of states, for instance, the Nebraska Department of Agriculture, since I live in Nebraska, giving approval to certain companies or certain products to be able to be fed in the state. So there are state level regulations as well that sometimes can override the FDA approval process.
Mike, any experience on your side on that one?
I don't have much more to offer there, but I'd really like to know who in California to talk to, because I've got a good ag commissioner in Colorado that would, I think, be more than willing to look at it. You know, all this stuff, I mean, even like Wayne's talking about is poultry and the capping of that bedding. If you could feed it to those chickens, it's going to be continually added to the bedding as throughout the life cycle of the bird. So so much would be fixed if we could just get approval to feed. But you know, it's interesting. It's legal to feed ractopamine. It's legal to feed a lot of antibiotics that are extremely harmful. It's just, I think we're and of course most of us my age being pretty cynical, realize the power of pharmaceutical companies, and just the loss of Rumensin and Tylenol to these big drug companies. Just the loss of that would be in the billions of dollars a year.
Yeah.
So they're going to find
80% of their market.
That's right. And we would eliminate those. We would eliminate those if we could feed biochar.
Yeah. I had that discussion when we were in Austria, and I said, why aren't you claiming that this has no antibiotics in it? And they said the reason was they didn't want to take on the pharmaceutical industry. So they're being pretty strategic about it. Mike, I hear you wanted to answer one of the questions about dung beetles.
Well, I saw just in the chat there, the person said, you know, don't bring Australian dung beetles in to the U.S. because they could become invasive. Well, we have our own dung beetles. We have a whole lot of different species of dung beetles, and of course we promote those. We don't feed things in the mineral that kill that kill parasites, at least while they're on pasture. So we want to keep our pastures clean so that we don't kill the dung beetles. So.
Thanks. Wayne, a couple of questions for you on the poultry side. One is, what's done with the beaks, skins, feathers, claws that are that result from the processing of the poultry? Is there enough mass to char that as a useful product? And then there was an interesting question about, if you use enough biochar, could that in any way reduce the cost of ventilation or any other energy inputs in a poultry house?
Both excellent questions. The first one, right now, the poultry industry basically treats it as either compostable or just non-compostable spreadable waste. So it goes directly back onto fields after it's been ground up. As far as I know, there's not a lot of processing that goes on, other than some places do have some biogas units where they'll put it through a biogas digester to get rid of the methane that would come off and use that as fuel, and then it goes out to the field. So that question is beyond my control now. It may be that we can work with Shenandoah Valley Organics to get them to do something with that particular side of the waste, but that is, it still is high in nitrogen, even those kinds of aspects of the bird. So you don't really want to lose the nitrogen when you make biochar. It's not that isn't the point. You'd rather use low nitrogen waste products to make the biochar if you can. What was the second part of the question? I answered that one.
Whether using sufficient amounts of biochar in the bedding could have an impact on the energy uses or the cost related to ventilation?
Oh, I think so. And that's a big question, but it depends upon whether we can get enough to actually test that. The farmers that that have seen this, and the one farmer that is doing it with us is really enthusiastic about biochar, and I'm sure he'd let us increase it to the point where we could test to see if we could lower the ventilation costs, because energy is a big issue in this whole thing, along with just the feed costs that they've got. And if it increases the efficiency of the feed use, that's where the farmer is going to get another boost to his market. But we haven't done enough yet at this point to really make any definitive statements about that. Now, I am in a classroom, and I am actually going to lose the classroom. So I'm going to have to take my leave for a little bit and maybe get back on in my office if I can. So I'll close down here and then try to get back on in my office. Thank you.
Great. Thanks. The other option they ought to test is putting it in the walls like I have in my biochar wall here to help with humidity. I'm not sure if it will help absorb ammonia, but it might be worth testing. There was a question about, is anyone using the IBI testing protocols to determine the quality of the biochar products added to animal applications? Well, right now, the only standard, the material standard that IBI has is related to its use in soils. That's largely because the standards apply mostly in North America, and right now it isn't allowed in animal applications. Well, it is for manure management. It's just not very widespread. But I think we need to understand a bit more about what properties are relevant to its use in, say, manure management, so that we could tweak the current standards to apply to different end uses. But it's definitely under discussion. And Mike, there was a question about charging the biochar. Do you want to talk about that from the soil amendment side of things?
Yes, I was just typing an answer in. When we sell bone char at our store in Colorado Springs, we recommend that they soak it in compost tea. So if they got a compost pile at home that they've collected, make some tea and soak it. But the point of charging is to get those microorganisms moved in and put into all their little condominiums inside that biochar, because it's got all those surface areas where microorganisms hang out, and that's the real value of the biochar. It's not the char itself, it's the home that it gives microorganisms whose exudates then feed your plants. And then of course with the char at our cattle operation, that's inside a manure pile and a compost pile for 90 days. So it's fully charged and it's ready to go to work as soon as you apply it onto the soil.
Great. A question about what's the difference between making a charcoal from wood and making biochar from wood? Heather, I'm sure you have a good answer to this.
Yes, well, I would say that it really has to do with the process. Typically, we think of charcoal as being kind of more of like a smudge pile, right? And biochar is a much cleaner process in the creation of it. But at the end product is very similar. So we really are talking about process when it comes to the difference between like a charcoal and a biochar.
Right. And sometimes it's a temperature difference. You can use lower temperatures when you're just trying to dewater it. versus if you're trying to get a higher surface area for certain kinds of biochar, then you would use a hotter temperature. Andrea, do you know much about the biochar you've been using in terms of, you know, the temperature and all that? You said it was woody biochar, but was there anything else about it that you think is relevant?
Sure. So, yep, all of them were wood-based biochars. We have tried a couple of different ones. One was made from pistachio shells, and the others from ponderosa pine. We've tried a couple of different temperatures. Again, we're just scratching the surface in terms of how biochar could be made. One of them was a very high surface area. I would say, I think it was 426 square meters per gram, if I remember correctly, and would have been a higher temperature biochar. And then some that were more down in the 300 range, so a little bit lower temperature, lower surface area, trying to get a range in biochars to test, but really have only done it in a couple of applications so far.
Interesting. Harry, keep me honest here with some of the earlier questions if you want to throw some of them in. Oh, is there any work being done to charge biochar with wood vinegars as a source of additional nutrition for animals?
I've read stuff, especially Stephen Joseph out of Australia has done a lot of work on this, and I know that there has been mostly positive results, but I have not done any myself, so I'll cease from this.
Anyone else? That's a tough one because wood vinegar is just about as variable as biochar is. So, you know, there's so many variables there that you'd have to introduce to the equation.
There are a couple of questions early on about the differentiation between biochar and activated carbons. Does anybody want to take that on? If not, we'll follow up. We'll be taking all the questions and getting the answers to them and posting them on the website.
The way I usually answer that one is there's usually activated carbon is made from either fossil fuel derived products, coal, petroleum, peat. It can be made from very hard renewable biomass such as coconut shells, whereas biochar is made from a much broader range of organic materials. The energy involved in creating biochar versus activated carbon is quite different. It's very high temperatures, and there's an activation process when it comes to activated carbon. So it is a pretty high embodied material as opposed to biochar, which is a low embodied or carbon sequestering material. And then the properties of relevance. Generally what you're looking for, well, it depends on the end use, but it's a high surface area, high adsorption capacity, which could be the case in biochar as well, but it really depends on what you're looking to use that biochar for. It could be more the cation exchange capacity or the pH or something like that. But at the end of the day, the main focus for biochar is its stability in terms of not returning to carbon dioxide. So as long as it's below a certain hydrogen carbon ratio, then and it doesn't have toxins, then that's what we consider biochar if it's being used in a way that preserves the carbon.
Mike and Andrea, there's an early question that I think is kind of interesting, and I'm just going to read it off. In Australia, our governing livestock industry body has a problem with using animal bones as a stock feed. What regulations do you have to allow it, or is it only for land use?
Is that for me, Harry?
You are, and Andrea.
Oh, okay.
Anybody else that wants to pitch in too?
Well, in fact, if you want to feed bone char, you can do it. I've got approval to feed bone char in Kansas and Colorado from the states, from both states. So I didn't get an approval from FDA or USDA, but it is approved. But I just don't see the benefit in feeding bone char as much as I would biochar that's higher carbon. the nutrients, calcium and phosphorus, are already in the feed they eat. I mean, that's not helping you a lot. I think it's more valuable from my perspective to put it in the soil for plant use.
Mike, there was a
Did you
question.
have,
Oh, sorry, go ahead.
Andrea, did you have something to add?
No, I think Mike covered that one pretty well. He would have a lot more experience with bone char than I do. Yep, I've really only worked with the wood-based products.
This question came up on the biochar listserv, actually, just about last week, about prions and the whole mad cow disease issue. So I looked it up and realized that prions are basically destroyed at 550 degrees Celsius, which is less than the temperature reached in most biochar making operations. So you really do kill everything when you're making biochar, and there should be no reason whether to use animal waste or plant waste. But I'm with Mike. I prefer the very high carbon material because that's going to be a greater benefit to the animals, especially with enteric methane with cattle, and then probably with ammonia production in the chickens.
Maybe we
Thanks.
could spend a little bit of time on the improvement to health, both in cattle and poultry. I think, Mike, you touched on it a bit, but I think this is really key. This is a really important aspect to discuss.
Well, Kathleen, if I had another screen, I would go back to my presentation and pull out the link to your report that you helped produce. That is loaded, totally loaded with the benefits to health and performance in livestock. So that would be my recommendation, is to just go to that link.
Yeah. Wayne, what about what you're seeing on the poultry side?
Well, the nice thing is that, you know, when you look at the chickens, when they interact first with biochar, is they get excited about it and go after it like they're going after a grasshopper or something like that. They actually like this stuff. And that is what increased the enthusiasm of the farmer. It wasn't so much all the sort of sciencey stuff that we like to focus on. It was the fact that the animals actually like it and they seem healthier to him. And so he was really interested. So I just point at the enthusiasm of the farmer when he first saw this chicken biochar interaction. And so the potential is there greatly, but I wish I could give some science to back up that kind of statement, but we're still working on that. And I don't want to speak beyond what you've learned with the Austrian experience with Hans Peter Schmidt and others whose experience has been really positive with the biochar in the poultry.
Yeah, I would agree. And I had a pile of biochar, a super sack full that had spilled on my front lawn, and the cows got out from my family's farm and they were all over it. I wasn't sure if I should be mad or glad. But I will say, last year I was on a panel with a dairy farmer from Canada, and one of the things he talked about that I'd never seen in the literature or heard about was that for the dairy cows that were feeding free choice biochar, they went from, I forget what the percentage was, but it was not insignificant, to 0 abortions for pregnant cows. And for him, that was worth its weight in gold, because the biochar wasn't costing him that much, but he found, and that speaks to the pesticides that can be in a lot of the food that cattle are eating these days, and pulling those toxins out and making the gut a little more healthy. So I think that and the hoof health can be better, but there's been some studies on the dairy side that talks about the quality and the quantity, consistency of milk production being better for cattle being fed dairy. But again, it's hard to replicate those studies here in the US because of these FDA bans. I know in Canada, they have a little loophole there where biochar can be used as a feed dye, but they can't make any of these health claims, but they are doing a lot of testing and don't have the hurdles that we have here in the US because of that. So, this is a pretty specific. Is there a particular crop that high calcium, phosphorus, or bone char is particularly apt for? Mike?
I need to ask my gardener expert. I can't remember if he said it was really, really great on tomatoes, but not so great on something else. I don't recall. But yeah, there are crops out there that love calcium, or love phosphorus, and there's some that don't appreciate quite so much. So, I'm not knowledgeable enough about that. But the reason one of the real reasons I got into the real production of biochar is because of Scott Wilson here in Colorado Springs, that has a gardening YouTube channel. And boy, he'd be the guy to ask. But I mean, when he found out I had biochar, he just couldn't believe it. And it was in all of his garden beds and his schools that he was teaching at, and he's done some really great videos on the use of biochar, bone char and biochar. So it's Scott Wilson. He's got a YouTube channel, gardening YouTube channel.
Someone was asking if it's necessary, not that we're promoting the use as feed additive yet in the US, but if it's necessary to add molasses or any kind of sweetener to entice cattle to eat it. So Andrea, in your experience, have you needed to do anything like that?
Yeah, so I don't have experience necessarily feeding it as a individual feed or supplement. Mike, you can probably speak to that a little bit better. We did mix it into a total mixed ration for feedlot cattle and had no problems with consumption, no sorting of it out or any problems like that. From just videos and things I've read as far as them eating it. The molasses maybe helps as much with dust control and keeping it in the tub, maybe even slows down consumption a little bit where they have to lick it instead of just, taking big bites and things. But Mike, you probably have better answer than that.
Yeah, there's no resistance to eating it. Typically if it's fed at, 1 ounce per animal per day, they don't even know it's in there. It's in a totally mixed ration. So yeah, there is no problem in getting them to eat it.
There was an earlier question about whether you can feed it to dogs and cats. My understanding is that there's no restriction on that. I haven't seen a lot of it in pet stores, but I don't know if anybody else.
It'd be good. We've got a cat litter with biochar in it. It's very popular. It essentially eliminates the smell of your litter box. Kathleen, when you talk about activated charcoal, I'm not nearly now as inclined to want to use it when I eat the poison berries. I think because of its fossil fuel source, I think I would prefer the biochar to take care of the poison berries. And in fact, I did that this fall. There was this beautiful bush of berries in my backyard that was hidden under another plant. And I discovered it, and it was a nightshade, but they were delicious, but I didn't know they were a nightshade. And so I got really kind of thinking about it, and I got my little phone app out and I took a picture of the plant, and it's this nightshade berry. Well, no problem. I just got me a big old spoonful of biochar. I had zero problem with the consumption of that. But activated charcoal, I mean, how could it be approved and biochar not? That's pretty ridiculous.
And that's interesting that you bring up that you would eat a spoonful, right? There are actually fewer regulations to get directly into the human food market than into the livestock feed market to become human food.
I know people all the time that eat biochar. I mean, it's what it's what we're used to doing as humans for stomach and digestive upset issues, and we know it works. But I sure would prefer to consume some good, clean biochar as a petroleum source to activated charcoal.
Right. So maybe one last question, Harry. There was somebody asking if a veterinarian can prescribe biochar, which I don't know. Andrea?
In Canada, they can. I don't believe here in the US. That's a second loophole. So yeah, if we do have, it looks like a pretty international audience. And in Canada, like you said, there's the loophole as a food coloring agent, but also that veterinarians can write a prescription with biochar. I'm not for sure about Europe. Seems like maybe there too, but obviously they don't have to go that route most of the time.
Right. Right. We may have missed a few, Harry, but I think we're coming up on the half hour there.
Yeah, and I wanted to thank everybody for sharing your knowledge and experience. Kathleen, thanks for moderating the Q&A. My internet's been dropping in and out, so I appreciate you taking it over.
I can relate.
Again, I want to thank the Forest Service for their support on this entire project and the ability to produce these webinars. They've really been great. And we've got one more in this series on stormwater management that'll be February 9th at 2 o'clock. So if you're interested in that application, please sign up and tell your friends and family. And with that, I guess we'll sign off. Thanks again, everybody.
Thank you.
Thank you. My class gave me a thumbs up when they left, so it went well with the students too. Okay, thanks very much.
Good. Thanks, Wayne.
Bye.
So.